Okay, hi everyone. Oh, um, so it's excuse me. So it's good to be back at Surge, and I'm continuing my tradition of giving a brand new talk at Surge, which hopefully this year will go well as I think it has before. So I'm at Crucially at Twitter. How many people saw my talk last year or 2 years ago? So a fair amount. I'm the founder of Fastly, which is a CDN. I used to be CTO of Wikia. Before that, I used to work at 6apart and LiveJournal and various other open source stuff. In previous life, I did finance and other boring, soul-drenching stuff. So I'm going to be talking about what is a CDN and how do they work. So how many people in the audience use a CDN? It's less than I suspected. I'm curious why not everyone uses them for absolutely everything. So if you have any questions about CDNs or what I'm talking about, just interrupt me at any time and just ask me and I will divert and try to explain. So to start off, does anyone have a question about CDNs? No, apparently they're clear. So what is a CDN? It's a content delivery network, content distribution network, or as I've heard once or twice, a cloud delivery network. Yeah, it's pretty awful. So most people see CDNs as a gatekeeper between them and their users, right? Like they're this magical thing that my clients connect to that fuck up my HTTP traffic, my content, my TCP timings, my debugging, my log files, my IP numbers, pretty much everything. And my background as a developer, you kind of had an incentive to try and get around the CDN because it was imposed by people that imposed it on you, and it kept breaking shit. So unfortunately, you need a CDN. Like if you have a lot of traffic, you cannot actually survive, or you shouldn't size your systems to survive without a distributed CDN. So you need it. They kind of suck, and you're back to needing it. And you're forced to use products that, at least for me in my past, infuriated me whenever I had to touch them. So I do run a CDN. Fastly is a CDN. So I'm going to try and not be vendor biased, which is pretty much impossible for me. But if you feel that I'm going too far in Fastly's direction, then just shout at me. So there's another talk going on right now about caching on the inside of the data center, I believe. Kate, I would love to see that talk. And CDNs is actually about caching as well. But it's about caching outside your data centers, but caching in a more restricted environment as close as possible to your user. And we have to stop thinking about it as a server that keeps shit close to the edge and think about it as something that's part of your entire stack to be able to deliver really, really fast content to edge or to end users. And most application developers don't think of CDNs that way. Most organizations don't think of CDNs that way, but they are an extension of your caching strategy. A caching strategy that we have developed over the last many years inside. We have caches on every layer, like we have the disk cache, we have the database caches, we have mem cache, we have like in-app caches, we have caches everywhere, and we've developed techniques to dealing with them that we have not translated to the CDN space. And what the CDN is just a very large distributed cache that, if used correctly, adds a lot of performance and cost savings to your system. So my view is that CDNs make shit fast. Like that's the job. And we do that by beating the speed of light. Right? Like it's the only way to beat the speed of light. It's caching. Like we've failed every other way, sadly. So if you want to deliver content to Europe faster than 200 milliseconds from the US West Coast, well, you can't. Like, the only way to do that is to use a CDN or have your own data center or own presence in that region. So how do they work? This is how most people view CDNs. Right, like one big black box. And my impression using CDNs was always that this was what people expected or what the vendors wanted you to see. Like this magical entity that randomly did shit for you and mostly did shit well enough. But all in all, a black box. So what does a CDN actually do? So the first step is to find the closest node and send the user there. So Tom spoke a bit about Anycast, and I'm going to probably botch the subject a bit because I'm not actually a BGP expert, but I will cover that. It is critical for a CDN to find the closest node, right? Because otherwise we're not doing our job. So there are two ways of finding the closest. There's two ways of directing traffic. You can do it using DNS, or you can use it doing Anycast TCP. How many people here are like familiar with Anycast TCP? Okay. Well, if you disagree with what I'm about to say, then please let me know. I'll happily have that debate. So somewhere a long time ago, well, DNS uses the location of the resolver to give out an IP address where your traffic should go, right? So if you are in a resolver that happens to be in Ashburn, we'll know that you are most likely in Ashburn. This breaks with OpenDNS, Google DNS a bit. There are ways to work around that. And you can do that using either IP geotargeting or Anycast DNS, or a mixture of those two. So what is Anycast? It's a network addressing and routing methodology in which datagrams from a single sender are routed topologically nearest node in a group of potential receivers, all identified by the same destination address. So many years ago, I was reading Stephen's probably network programming or advanced TCP, and I found this TCP Anycast or Anycast. I'm like, wow, this will solve all my fucking load balancing problems. It will be great. And then I tried it. And so what this actually means is magic, right? Like, it's magic. So for the people who saw my talk last year, that talk was basically how magic is not to be trusted and doesn't work. And if you call something magic, it's because it doesn't work or because you don't understand it, most likely both. So how does Anycast work, right? Like, you want to reach 10, 10, 10, 1. It's pretty easy, closest path, right? So now you add this topology, and you get like that. And if you're lucky, your router does equal cost multipathing, where it hashes the flows and keeps them to the same upstream and so on. If you're unlucky, this happens. You send a SYN, you send a SYNAC, you send an ACK, and you get fuck you back. All right? So I think Anycast TCP or Anycast is snake oil, right? It does not actually work. Like, if you're using a CDN or a product that relies on Anycast in the public internet, it does not work. It works on a tightly controlled network. Like, if you control all your routers, if you control all your networks, it does work. This is the latest KAIDA internet map I found. That is not a tightly controlled network. Right? Maybe if you paid a little free NTT and whoever else is now top 3 enough money so they would make sure they did correct hashing for all your traffic, you could maybe get away with it. But it just doesn't work. Anyone disagrees? Please disagree. No, it's sad. So I actually ran, I did some log analysis. So it's 4 hours of Anycast connections. from around the world. And so 75 million connections from 700,000 unique IPs. Right? Only 45% of them, and this is a well-run Anycast network. It's Tom's. 45% of the client IPs were stable over a four-hour period. Or put it this way, 55% of your clients had a chance of hitting 2 networks and getting the fuck you from 1 server. Right? 55% went to 2 or more. There were a bunch that went to 2, a bunch that went to 3, but 10% went to 4, and then one guy ended up at 8 locations in 4 hours. 8 locations. And most of them were understandable, like Ashburn, New York. They're really close to each other. The 8th one was weird. And then some of them were India, which ended up in Frankfurt half of the time and in Singapore half of the time. Both from a routing point of view kind of make sense. Like that's where the links go. Or Eastern Europeans that ended up half of the time in Frankfurt and half of the time in Amsterdam because that's where they peer or that's where they get transit. But if you rely on this for your TCP connections, well, that's what you get, right? So what we do, yeah, that's the promise of Anycast. So the beauty of Anycast, as Tom talked about earlier, is for UDP it works, right? Because UDP is just one packet, doesn't need state. So that's what we use. And so this is a CDN transaction. If you cut out a cache hit, right, you don't go back to origin. Or if you have a shield or a mid-tier. How many people are familiar with the shield mid-tier terminology? Not that many. So shield mid-tier is CDN terminology for we charge you twice for bandwidth when you cache miss, but we serve it faster than your origin does. So imagine that your servers are in Ashburn, and you have a shitty load balancer that doesn't know how to do keep alives. And you have a shitty configured Linux machine that doesn't transmit data at high speed. We can, or CDNs in general, can configure our Ashburn POP as a shield or a mid-tier, and then every other node will go to Ashburn, to our machine in Ashburn, that then will go to you. And because we keep long-running keep alives, but I'll go into more detail later, that has a significant performance increase. Now, if you can just do keep alives on your own, then yay, that's way better. But the other interesting thing with shield and mid-tier is that you can effectively reduce your origin request to 1, no matter how many cache misses are happening in the network. So cache all the things, right? So I built Fastly at Wikia, right? We're a content site. And we needed to make our stuff faster. And we didn't want to put a copy of MediaWiki in each country, because MediaWiki is really shitty and very hard to run. It's a large PHP MySQL mess. So we built our own CDN. And we built our own CDN because we wanted to cache everything. So if you go to wikia.com, pretty much everything is cached. And it's coming out of the cache at sub-millisecond speeds. Like 50th percentile is like 200 microseconds, 99th percentile is like 800 microseconds. So not only are we beating the network latency, we're also beating whatever you do on your app server. I don't fucking care if you run Nginx or Apache or whatever the fuck you run, right? Like, you're not going to deliver a page result faster than 200 microseconds. Like, it's not going to happen. Side note, I find it very amusing when people discuss web servers and they go like, this is faster or this is faster. And then they have these shitty, large, dynamic language apps behind them. And you're like, seriously, like, Nginx might be faster, I would guess 25 microseconds than Apache, but your backend app takes 200 milliseconds. Like, why do you fucking care? Fix your app. Like, your web server is rarely your problem. Like, the web server is our problem, right? Because we don't do computation on behalf of users. Well, that's not true. We do for SSL. But we do deliver traffic as fast as possible without doing computation on it. So linked lists matter, right? Like linked lists suck for modern CPUs because of cache miss, locality, etc. Most people, that shit does not matter. Most people do not need to generate vast quantities of assembly, compile them, and dynamically load them into your runtime to do virtual host dispatch, like we do. It's pretty awesome. Like, we should actually open source that. My laptop can now do like 400 million virtual host lookups per second. And there's no memory allocations. So if you get in a mindset of caching more rather than less, if you get into a mindset where like the default is, can we make this cacheable? Which it already is when you talk about inside your data center. When you talk about how do I like make my database survive? Well, you throw in memcache, right? If we start thinking of that at the edge, not only do we drastically reduce the number of memcache and databases we need all the way through, but we dramatically increase the delivery time to the end user. Dramatically. I was hoping someone would disagree on anything I said. That's what I meant. What did I say? Well, you know what I meant. So this resolution is horrible. This will be fun. So part of the talk was like, how is it running a CDN? Most of us have Fastly come from very large website backgrounds. And running a CDN was an interesting transition in mindset. When you serve ad-supported pages that have a fairly low CPM, because everyone has a fairly low CPM except Google search, and you lose 10,000 requests out of your, I don't know, 400 billion requests in a month or whatever, you don't really fucking care, right? Like, yeah, one blip, a couple of users show something wrong. In fact, a lot of outages are actually not worth fixing if they're small enough. Like, you have 70 million unique users. 100 of them saw something wrong for 2 minutes. Like, you don't care. Running a CDN is different. You're paying customers that care on behalf of their users. So I'm used to pushing code in previous jobs at about 50. I actually got a tweet question about, someone tweeted a question at me earlier, but I'm used to pushing 50 times a day, 25 times a day. Like, it needs to be pushed, just fucking push it, right? Breaks, revert. If it breaks, you roll back. Downside of caching, if you push something that breaks and your cache, and the broken JavaScript or CSS is cached, and the cache rolls over a 24-hour window, and you push in nighttime, and people go to bed, and you wake up the next day, like 10 hours in, and you suddenly get reports, but none of your active pages are broken yet, and then, like, your most active pages full of the cache refresh broken, and you realize that by now 40% of all your cache pages are broken, and you have to do a purge all. That is exceedingly painful. Exceedingly. So that is the one downside of that. But at Fastly, running a CDN, we push once a month on the caching layer, if that. Right? It is a very very distinct mind shift in running a service compared to running a website. So upgrades are much more manual. They have to be watched way more. You have to make sure that you don't create some weird traffic situation. You have to roll them. Now, the good thing is we have data centers around the world, so you can just do it whenever you want. And so I'll actually do this. So this is a live caching server on the in the West Coast. It's doing about 3,000 requests per second right now. CPU utilization would be non-existent. That was weird. And that I don't want to do. So I'm just going to take the server out of rotation, which means this server should pretty much double. And at the same time, I'll go here. What? Oh. Thank God. So we're heavy users of Ganglia. Who was at the monitoring sucks buff? Well, no. So we're heavy users of Ganglia. We even go to the extent that we run Ganglia on our switches. By the way, if you haven't had the pleasure and joy of using an Arista, you should go out and buy one right now. It's like the only piece of hardware tech that I actually approve of right now. I'm serious. They're delightful. You can get SSDs in your switch. We don't have those, but so this is so it's 1,000. Is this going to kill the Wi-Fi? It might. It's 1,080 graphs. I was talking about that on the BOF yesterday. This is how we do correlation of events. I'll let that load. Okay, so this should start draining any second now. In the meantime, I'll go back here. So I said earlier that I think you should use a CDN for all your traffic, or at least all your HTTP and HTTPS traffic. Like, there's no reason why you should terminate TCP connections at your data center. Like, absolutely no reason. And even for uncacheable content, which in the CDN terminology is called DSA, and it's a huge fucking scam, right? Because what DSA actually is a well-run CDN that doesn't cache anything. And since the biggest cost for us, well, bandwidth, but apart from that, the hardest part is dealing with disk latency. If you don't have to cache anything, you're reading it off the network into L3 cache, and you're dumping it out of the network out of your L3 cache, and then you get rid of it. It's really, really simple. And DSA, people are familiar with DSA? Very few, okay. So DSA is like magic pixie will make shit faster by being faster than the internet. And all it really is keep alives. TCP keep alives, HTTP keep alives. There is this belief that keep alives should be off on SSL servers, that it should be off on various servers because it increases, I don't know what. Like, keep alives is fucking key to making anything run fast over long distances. So if you assume 200 milliseconds from Amsterdam to San Jose, a normal connection will look like this. 100 milliseconds for the SYN, 100 milliseconds for the SYNAC, 100 milliseconds for the request, and a slow start reply for 100 milliseconds. Right? That's 400 milliseconds to get the first byte of reply. Now, a typical slow start reply is 2 or 3 packets. So between 2.5 and 4 kilobytes of content. Before you have to pay another 200 milliseconds round trip to ACK that before you'll get any 100 plus 200 to get the next set of data. Slow start is incredibly important to understand. This is what happens when you use a CDN. SYN 20, SYNAC 20, request 20. And then we paid 100 millisecond across the internet. over a already existing connection, right? And that's the key. Like, it's an already existing connection. So if we remember how TCP windowing works, like, do we? Seriously? TCP windowing. You can only have as many outstanding packets as the window allows, and after that, you have to wait for them to be acknowledged, right? So if you have a long-running connection that is at full open window, you can send a lot of packets down that shit before you need an ACK, right? If you're a new connection on a default configured server, well, Linux now changed that, so it's 10, which is what we do, but you get 2 or free. 2 or free, right? So if you give us the reply in one go, it's 100 milliseconds to get the entire reply back to the local CDN node that will then do the slow start blah, 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 blah with the client that's only 20 milliseconds away, right? So it's 400 to 240. With SSL, which is 2 round trips, right? SSL is 2 round trips. You save a lot of milliseconds just to get the first fucking byte on a completely uncached item. Then you can play some nice games like a common SSL configuration is use an SSL buffer of 16K, and an initial congestion window of 10 gives you about 14K. So you have to do an extra round trip for those last 2K to be able to decrypt it. So if you actually have a lot of data on the server, you can actually get around that. Okay, let's go back to our live server here. So traffic's now dropped down to a substantially lower, and this server is now up to 6,000, and the load is still ridiculously small. And if you look at this graph, the overall traffic hasn't shifted. But in a very short period of time, the actual traffic dropped. And this is actually a great way to find bots. Like, choose a server, remove it from DNS rotation, wait 2 hours. Whoever is still hitting you, just ban them. Just straight off. That will include the Bing bot, which doesn't fucking do DNS revalidations according to TTL. That's the only legit bot that I found that doesn't do that. Everyone else is like some random fucking distributed spam bot shit that goes on all the time. You have to wait, especially like on the West Coast, you have to wait longer because Australia doesn't respect TTLs as well. It's true. DNS-based failover works really well in the US and Europe, and like London will fail over way faster than Frankfurt because Frankfurt does all this shitty traffic from far away. Also, Frankfurt has a lot more bots than any of other POPs because of the catchment area. Like, you'll literally see some mild forms of attacks hit Frankfurt and then maybe get to Amsterdam and then not get any further. Let's see, go back to here. No. Oh yeah, I was going to show this. So this is how this is how we actually look for errors. Actually, it's kind of boring. This is one machine, and we haven't gotten into the application metrics yet. This is each hard drive. This is key to figuring out what happens post facto on an event. We have found the weirdest forms of correlations by looking at this. So one we found was under an event where we get outbound packet loss. We saw And we didn't know we were getting outbound packet loss initially. What we actually saw was an enormous pressure on the Linux memory subsystem. And that then caused latency delays in other systems because if you watch my talk from last year, the Linux memory system is retarded. Sorry, stupid. And will like pause applications if they do too much. And our servers do, you know, they do a lot. Like if you do, SAR. That's the one I want. Right, so we're doing a fair amount of page faults and faults a second. So if you get something that messes with memory, it's actually apparent really, really quickly. So what happened was, what happens when retransmissions go up? Well, if you are saturating a 10 gig pipe, and your average latency to your customers is 200 milliseconds, you're keeping a couple of hundred megs of packets around, 1,500 byte-sized packets, ready for retransmits if something happened. If you then have a network latency event where the amount of packets that you need to keep around significantly in a very short period of time goes up, the first thing we noticed was actually that the memory system became under a lot of pressure, which then induced latency. And then we saw the spike in retransmits. But without having 1,000 graphs or so, like it would actually be, I think, close to impossible to retroactively work that chain through. Like that's the only reason that we managed to do that. This is another one. So this machine has 192 gig of RAM, and I forget what the command is. So a word on SSL. You run top, you see HTTPD in there. So we run Apache for SSL. And I get a lot of questions about why Apache? Apache is slow, it's memory inefficient, blah, 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 blah. So first of all, memory inefficient, I don't fucking care. Like, I have 192 gig of RAM, right? Any idea how cheap RAM is if you're not on fucking EC2 anymore? Like, you can buy like a 256 gig machine with 2 Intel Sandy Bridge 8 core, like, so 16 cores in total for like $6,000, right? And you can push probably on the order of 50 gigabits per second non-SSL out of that, and probably about 10 gigabits per second of SSL out of that machine, right? And it's 256 gig of RAM. Like, the DIMMs are ridiculously cheap. The reason why we use SSL is because event loops don't work for SSL. Like, NGINX does not work for SSL. STUD does not work for SSL. Anything that's based on an event loop does not actually work for terminating SSL. Does anyone want to tell me why? Say what? Yes. The handshake is CPU intensive. And the handshake on a Sandy Bridge probably takes about 800 microseconds. So every time someone does a handshake, you block the event loop. And I don't fucking care if you're running 16 apps, like 16 like instances with their own event loop. Every time someone does a handshake, you block by 800 microseconds, right? And so what you see is it's really fast until you reach a magic point very quickly where latency starts going up and falls over. So on one of these machines, I could probably get NGINX decent latency to about 12,000 SSL requests per second. I got Apache to 48,000 SSL requests per second, 10K requests, doing so about 5 gigabits per second of SSL, with 32,000 connected clients, free connections, free requests per keep alive, and free connections per handshake. right? So we were doing like a couple of thousand handshakes a second, 12, 14,000 connections per second, and 48,000 requests per second before we hit, and the latency was stable. I tried to find a graph, but I couldn't, so sorry about that. And so when you hear event-driven, you go like, oh, that's awesome. It is awesome if your machine isn't doing anything but shuffling bits around. If your machine is actually doing something computationally, then, or something that you would have to time shift from, then event loops don't work. And so we run Apache with 64 processes or 32 processes and a total of 96,000 threads. Right? Turns out the kernel can do it. You should use our branch because we removed like 3 lines of code that saved like 40% of the CPU because of times overhead. Apache by default calls times on every thread for every request to the status page, basically. And times the syscall is pretty expensive. So yeah, we ended up with Apache, and it works really well, and it's faster than, sadly, or for better or worse, it's faster than any of the other alternatives that we've tried. And if you go to GitHub, our Fastly repo contains our version of Apache. Let's see, this machine is now down to probably purge requests and nothing else. So I'm just going to enable it again. And if you think of trying that URL from outside the network, it doesn't actually work. It's localhost only. So I talked about slow start. So if you use a CDN, by the way, we're starting around out of time, so questions, be ready with them. Syscontrol that you should really use if you're talking to the internet is no metric save and slow start after idle to 0, because by default, according to the standard, but we don't really care that much about the standard. We do, but not really. After 3 seconds, you go back to slow start. So you're kind of negating keep alive. So you should change that on your servers today. Just do it. That and NUMA. So S3 is a good example of that. I noticed fairly recently that S3 now lets us do keep alive. So I've literally seen connections to S3 that have downloaded millions of requests. I could have been blind when I saw it, or delusional, but that's what I saw. One of the cool things running a CDN is we actually have S3's TP99, TP95, TP90. If you're an Amazonian, you know what that means. Because we see enough traffic aggregate from users that use S3. It fucking blows. So that's the latency heat map. And you can see the ones that are like up to nearly 4 seconds, 3.5 seconds, and then 2 seconds, and then this is from Ashburn. Like this is with, so most of people that use S3 with us will shield for Ashburn. And our Ashburn pop is by ping times, about 2 milliseconds from S3. And to request anything takes at least 60. But so this is filtered for Ashburn. And you can see the 2 second, the 3.5 second, but most of them are, pretty bad. This is our global mislatency for everyone, which is not that useful, but shows how much time is saved. So going back to the theme cache everything, like if you can cache everything, like the reduction you get, I'll repeat that because it's true, in origin cost is enormous. Like, and you go like, hey, I went from 40 to 80%, like great, you saved half of your origin. You went from 95 to 99.5, you can 10x reduce your origin, right? Like 98 to 99 is as good as an improvement as 40 to 80. And like most people will see, oh, I hit 90, and it's good, or 95, it's good. Like, no, it isn't. Like, try to go as high as you can, because, well, yeah, numbers speak for themselves. So, we have customers who, in production, on each edge location, will cache like 200, 300, 400 million objects, and achieve, really good hit ratios, so they never have to go back to origin. We can do that because we rock and we use SSDs. Could be the other way around. But like we had one customer who accidentally let their cache hit ratio slip from 94 to 84%. And I think they probably spent like $400,000 in capex that they wouldn't have if they just fucking had their regex correct for what was cacheable or not. Because on a high volume site, that's a lot of traffic you now need to absorb. One final warning though, when you do caching, vary. How many people are familiar with the vary header? So vary is a second level hash lookup. It's actually really annoying for us because we have to compute the hash key based on what you tell us. Then we have to look up the object. We have to read the vary. And then we have to recompute the second level hash key based on what the object says that is varying on. And usually you vary on accept encoding. But some people will vary on user agent, which is completely fucking useless. If you looked at how many user agents there are, like everyone is unique. Refer has some uses. The best one I ever saw was accept encoding, cookie, refer, user agent. I'm like, literally, you will never get a cache hit. Right? Like, you just won't, like, if the same user came from the same referrer, he would get a cache hit. So not very useful. Cookie is useful if you whitelist which cookies you are varying on, which sadly there's no HTTP standard for. But things like Google Analytics will mess up or will inject cookies into your domain and therefore make your cache hit ratio dramatically drop. Even a short TTL can be very, very helpful because like we have a customer who runs a 5-second TTL with a day of stale TTL. So if their origin goes down, we'll keep it around for up to a day. And they never see, or they only see one request per object per 5-second to their origin, no matter how much traffic they see. Right? Like they completely absorb any kind of massive traffic spike at the edge, which is where it should be absorbed. Right? Like it never even goes back to them. So if you have kind of flashy traffic, even a 1-second TTL is the difference between n number of requests per second to your backend and 1, which is a fucking dramatic difference. So, like, why don't you cache? Just cache. Cache more. You don't even need to use Fastly. You should, but you don't need to. But like, to create a better user experience, we have to start using edge caches, and we have to start using them more. Because everything else goes faster except speed of light. Yeah, that's sadly how it is for now. So, any questions? Say what? I can't hear. No, we haven't. It came out pretty recently, and we've had no reason to switch. I don't actually know if it's event-driven or threaded. Say what? The question is if we tried HA proxies SSL. I have fundamental philosophical problems with HA proxies view on keep alives and HTTP 1.1, as in they're wrong. The website is wrong. I know that the website doesn't reflect reality anymore, but it's still wrong. But it came out like a month ago, and we haven't had time to look at it. So HA proxy for the longest time did officially. So the question is, what's wrong with HA proxy and HTTP 1.1? HA proxy for the longest time did not believe in keep alives. Like they had this huge rant up about how keep alives are bad and how they destroy performance, which is just wrong. And Nginx has a similar problem where Nginx, I think it's fixed now, but didn't used to do keep alives to origin, which is also not ideal. Like you want your keep alives to be running as long as possible, both to the client and to the server. Like keeping 2 million TCP connections open is not a hard problem.
we need we need to talk about your TCP Anycast study
Sure.
later.
It doesn't work. You can't, you put it this way, you can't prove it works, hence it doesn't.
I can. I'm not saying you should do it, but you can.
There were talks about invalidation in HTTP protocol to have it in RFC somehow. Do you guys look into invalidation of your caches anyhow, like from clients' answers?
So, right, so that's the request for if you don't have API key checking on purging turned on, that's all you need to do. And it was a miss.
But can you purge something else? Like if you say do the magic put request, delete everything. Okay, delete everything from other stuff. Like for that, like ID of some request, and delete all sub requests from cache.
So we support something called surrogate key support, where you can tag responses and you can purge by tag. And every object, 2 objects or 10 million objects that match that tag are instantly wiped. Or you can purge by URL. And you can purge everything. We're firm believers in real time, so purge delay is about 120 milliseconds across the network. Any other questions? Come on.
One of the problems I've seen with CDNs is that you end up with, well, inconsistent situations. So like the French are phoning me up saying the site's broken, and I'll go and look at it and it's all fine because somehow the CDN has got out of sync in one edge node is giving a different response to another edge node.
So this goes back to the transparency black box I talked about earlier. Most CDNs seem to think that their pub locations and IP addresses and routing and servers are proprietary information for some reason. I think it's because they're embarrassed by how many they need. But we have an API call that will tell you which servers are responding to your requests. And if you give us a URL, it will give you the MD5 sum of each location. So, like, we don't believe that that should be secret, and it should be really simple for people to use.
Any further questions? Anyone? All right. Come to you.
Just want to know how you think a CDN should deal with a denial of service attack and what you've done on that.
Well, personally, I believe in what one of my employees termed active DDoS mitigation. Unfortunately, we can't really do that. But generally, we have more bandwidth than the attackers, right? And their upstreams are really limited usually because they're, So I believe that the way you deal with a DOS attack is you have more capacity than whoever is attacking you. And you just absorb the traffic. What we tend to see is really stupid DOS attacks, like someone fetching the same page 2,000 times a second, and you're like, great, that is really easy for us to serve, right? Like, we still see sin floods on a regular basis, and you're like, hey, is this 1998 again? And like, seriously. But I think as an attacker, it is way more cost efficient to attack an app than the CDN. Unfortunately or fortunately, right? Like, I can find a page on Wikipedia that if I hit it barely more than once a second will probably take the entire fucking site down, right? It's a talk I've long wanted to give the 10 ways you can crash a wiki on Wikipedia without even trying, which I won't give for a long time. But that's usually a way more cost-effective, is find an uncached page that you can hit and just go for it, right? So on Wikipedia, you can just do !action equals purge. I'll purge their mem caches too, for good measures. That's actually public, so I don't fucking care. But yeah, more capacity. Just throw it at us. We also have plenty of unused uplinks, so.
Any further questions?
He agrees with me anyway. He's just trying.
So can you go back to your study and let's just talk about it for a sec. So you were testing our Anycast.
Yes.
And can you talk about the technique that you used and how you collected the data? And then what I'm going to say is that your stability metric was subject to an end recursive resolver's RTT banding and selection algorithm. And so what you actually tested was the stability across our 4 different Anycast paths and not across any one single TCP Anycast stream.
So, yes. That does still not explain roughly, I would say, 25% of the data we saw. Like, it explains the semi-regional ones.
A lot.
Say what?
A lot.
Well, 75. So 25% of your traffic is broken if you're using TCP Anycast? Like,
well, I would be happy to stand up a lot of VMs so we can test this.
let's do it.
All right, on that note, I think we're going to have to give Artur a hand here. All right. And,
Oh, one more thing. There are T-shirts up here. I think they insult other CDNs, so if you want some, you should go grab them.
all right, we'll
Thank
take
you.
we'll take a short 10-minute break and then back in.